Alright students, good morning. We're going to run through a couple examples here. You should be on the first page of your packet for long division practice. Like your sub said, this is a topic that maybe will be one question. The other one that you'll do later will maybe be one question on the AP test. They'll be featured more heavily in BC for sure. So it's something that we definitely need to cover. But it's also kind of a weird, super specific case of integration. So I just want to highlight that if this is not clicking, keep trying, know the general idea, know the goals, but don't stress too much because you can get there for sure by the end of the year. You probably did this via long division with me last year, or Miss Santos. Some of you may have learned synthetic division. That works, but it doesn't always work for these problems because you don't always have a coefficient of 1 on that x. So we're going to practice long division here. And when I say long division, I mean the exact same algorithm that you used when you were in 4th or 5th grade applied to polynomials. So we're going to do the first one together, and then we're going to set up the second one, and you're going to finish it off. And then we're going to set up the third one, you're going to finish that one, and then we'll do one integration problem for this video. So here's our first question. Oh, by the way, I got a new stylus here that has a softer tip, so hopefully I get far fewer complaints this time about the loudness of my writing. But if you still don't like it, let me know. So here's our setup. The numerator of our fraction goes inside our division symbol. So here is our initial setup. Put that top part inside, and make sure you include every degree. And in this expression, every degree is already accounted for, so we don't have to add anything. You'll see what I mean on the next one, but everything has to be accounted for. And then the x minus 2 goes outside. So this is the same way you set this up before, when you were just using numbers. Now we're using polynomials. So our first question is, how many times, or really, if I did x cubed divided by x, what would be left over? Or another way, x times what gives you x cubed? And the answer here is x squared, and so we're going to put x squared right above the x squared term. And then we take this thing, just like your division, and we're going to multiply it by both of those two terms. So we'll say x squared times x, that's x cubed. X squared times negative 2 is negative 2x squared. And then just like your division algorithm, we subtract. So x cubed minus x cubed is 0. I'm not even going to write it. Negative 4 minus negative 2. The signs are tricky here, but really that's plus. So I get negative 2x squared. One step down. Now we do the same exact thing, except we only say, hey, x times what would give me negative 2x squared? Oh, we also got to bring something down. Sorry, we got to bring down the 2x. X times what gives us negative 2x squared? In this case, it's negative 2x. So we'll write our negative 2x right above the x term. And then we take this thing and we say, let's multiply it by both of these two terms. Sorry about that, both of these two terms. But I erase this line. So we say negative 2x times x, that's negative 2x squared. Negative 2x times negative 2, that's positive 4x. And now we do the same thing, we subtract. So the first term is going to cancel. And then our second term is 2 minus 4, so that's negative 2x. Bring down the 5. And then our last question, and we're getting there. I know this is kind of long. You'll get way faster and better. X times what gives you negative 2x? I think that's just negative 2. So just negative 2 goes up there on top. and then we say, okay, negative 2 times both of those things gives me negative 2 times x is negative 2x. Negative 2 times negative 2 is, and I'm struggling to move my OneNote here, is positive 4. So subtract that away, we get 5 minus 4 is 1. Now we don't have any terms left. We don't have anything else to bring down. So this 1 is your remainder. Just like your division algorithm, the 1 is left over. So we're going to add that to the end of your fraction. So we'll say plus 1. But just like if you're dividing numbers, it's 1 over something. So it's not just 1 by itself, it's 1 over x minus 2. Because that was the term I was dividing into everything else in the first place. The goal for this is that we actually couldn't have, if I said like, hey, integrate this thing, you actually couldn't do it as is. You don't have the tools. But if I divide first and get to here, I can integrate each piece. So that's our goal, is to put this in a form that I can integrate. I apologize for not mentioning that at the beginning, but wanted to mention it here. The goal is to find some way to integrate. The only way in this case is through long division. So that was a lot. Here's what we're going to do. We're going to do one more, and we're going to just set this one up, and then your teacher's going to pause this video and give you like 3 or 5 minutes to work through it and see if you can divide, and then we'll come back together and talk about the key. And I'll go faster this next time, since you will have had a chance to practice. So here's our setup. I'm starting to not like this new stylus because it does this weird thing. Okay. Here is where we got to make sure we include the missing x term, and here's what I mean by that. Inside my division symbol, we write 2x cubed plus 4x squared plus 0x. We have to include every single term, and in this case, the single term that we need to also include is 0x. Because when we do our division algorithm, we just have to have all those places held. Minus 5 at the end. So everything else looks the same, just include your missing terms. Okay, toss your x plus 3 out front. I know that skipped a little bit. What I want you to do right now is pause the video, and I want you to try dividing. Here's a hint. Your first question is going to be, x times what gives you 2x cubed? That's the place to start. So pause this video, try dividing, ready to go. Okay, let's roll through this one pretty quick, and then we'll do one integral example, and then you can try 2 more. So x goes into 2x cubed, 2x squared times, and then we multiply 2x squared by both of the terms outside. So we get 2x cubed plus 6x squared, and then just like your division, subtract. Supposed to be a 6 here, what the heck, there we go. That cancels, 4 minus 6, negative 2x squared. Bring down the 0x. It still exists, it's still a number, we got to include it. And then x times negative 2x gives us negative 2x squared, and that's why we needed to include it, so that we could save its place above the fraction. Now multiply that out, we get negative 2x squared minus 6x. And now let's subtract. I like to add parentheses in my subtraction symbol, just so I'm not confusing myself. So now 0 minus negative 6. So like 6x, bring the 5 down, and it's plus 6 at the end. X times 6 gives you 6x. And then multiply across, so 6x plus 18. What's my remainder? I'm subtracting here, it's negative 5 minus 18, so negative 23. So I'm going to add that at the top here, minus 23 over x plus 3. It's nastier, but I could integrate that now. And you'll see how here in just a second. So we're not going to do the other two examples down, right here, but use this for extra practice if it's really not clicking. I'll try and remember to put the key in the OneNote. I think it will be in there, so you can use that as a reference. What I want you to do now is go down to the bottom question on this page. This one. Now let's integrate. So we're going to practice one of these examples, and then you're going to go to your next page and do 2 examples on your own. So here's the issue. We can't use usub because there's no u, there's no inside-outside function. It's a little tricky. Number 2, it looks a little complicated, and the degree on top is larger than the degree on the bottom. That's a good clue that we got to do some long division. So let's set up our long division. The x cubed term goes inside, so x cubed plus 2x squared plus 0x plus 5. On the outside, x plus 2. If you would like, we can run through this again here, and we will pretty quick. But if you want, this video will be in the OneNote. You can pause this, slow it down, do whatever you want to do after class. So x goes into x cubed, x squared times. So I get x cubed plus 2x squared. Oh boy, something's fun's going to happen here. Both of those cancel. So bring down the 0x. Well, this is just 0x. That's kind of boring. That's okay. It'll work out, I promise. Multiply 0x by both of those. Subtract again. It's still 0. So this looks weird. But when I bring the 5 down, x goes into 0x 0 times. That just means the 5 is my remainder. So I get 0x plus 0. 5 minus 0 is 5, so 5 is my remainder. So I just get 5 over x plus 2. And that's okay, I just don't need to include those other 2 terms. So let's rewrite our integral. Again, that was the quick division, quick version. Let's rewrite our integral now that we have done that division for the fun part. Now I know this integral is actually the same as the integral of x squared plus 5 over x plus 2 dx. And now our question is like, could I integrate x squared? Absolutely. Could I integrate that second part? Yes, but it's maybe not obvious right away, but let's think about what we're actually saying here. So I'm going to change colors here for this, just so we can see this a little bit. This term, it looks a little bit weird, 5 over x plus 2. But what if I just pulled the 5 out front? So it's 5 times the integral of 1 over x plus 2. Now it looks kind of like a natural log, but it has that plus 2 on the bottom. So you could actually say this is a u-sub problem, and du is just dx. So then instead of writing 1 over x plus 2, you could just write 1 over u. And then we could integrate it pretty easily. From now on, you actually won't need to. Our trick from now on will just be, if I see a single degree term on the bottom, so just x to the first, I can just go straight to u sub. So that'll work every time, and we'll practice that more next week. But this makes our life really easy, because now I can say, hey, this is just x cubed over 3 for the first one, and then for my second integral, it's just 5 natural log of x plus 2. I had to give myself room, don't worry, I didn't forget, plus c. And here's our final answer. So the whole point in that long division was to make our function actually able to be integrated, because we don't have the tools otherwise. So if you see something with the degree larger on top, that's a clue. You got to use long division. So divide it, and then integrate whatever's left. Flip your page, packet to the next page, and try those 2 questions. Ready, go.